Now, after we have looked at the Charles law and the Boyle's law, there is another gas law, another very important gas law, which relates the mass of the gas with its volume. So that is known as Avogadro's law. And Avogadro's law, there is a number also which has been Avogadro's number. Okay, it has nothing to do with this law. So do not confuse the two things at all. Avogadro's law is actually, this is the law originally given by Avogadro, but for some reason this law was ignored for a long time. So to actually honor the scientist, later on we gave the number Avogadro number just to honor the scientist, but it was not, it has nothing to do with this law per se. Okay, so what does Avogadro's law, what does it say? It says that if I increase the number of particles, the number of molecules of a gas, its volume would increase linearly. Okay, and here is the simple demonstration of that law. Here we have a machine. In this chamber we have put some gas particles, okay, gas molecules. Now I have kept the pressure and the temperature constant, and that is very, very important. We are only changing one thing at a time. And what are we changing here? We are changing the mass. So the mass of the gas, how are we changing it? We are putting in more and more particles or removing particles from here, and that is how we are changing the mass. And if we plot the mass versus volume curve, then we'll see that as we increase the mass, the volume increases linearly, which means that there is a direct relationship between the mass and the volume at constant pressure and temperature. Actually, this does not only holds for one gas, but it holds across gases. Okay, so this is the original Avogadro's law or Avogadro's hypothesis. And what does it say? That equal volumes of gases. So if I take the same volume of various gases and I keep them at same temperature and pressure, then I will find that they have the same number of molecules. Okay, and that is very, very important law. Now here are some real life examples. Okay, so when we fill air in the balloon, what are we doing? We are putting in more and more gas molecules in the balloon, and that is why its volume is actually increasing. When we are pumping the air in the tires, we are doing the same thing in our bicycle tires, in our car tires. When we are pumping air in the tire, this is exactly what we are doing. We are increasing the number of molecules, because of which the tire would actually inflate. Now with that basic understanding, we'll do a very simple numerical on the Avogadro's law. Okay, so these are the three things which these laws, you have to always understand that there will be numericals asked on these laws. It is very, very important that you understand this. Okay, so the law is very simple. V1 by N1, these are the initial conditions, and V2 by N2, these are the final conditions. Okay, N1 and N2 are the number of molecules, some measure of mass of the gas. Okay, and what we are saying is that these two ratios are the same. So volume in the first case is 11.5. okay, so that is what we can find from here, and the N1 in the first case is 0.35. okay, what about afterwards? We have added 0.15 moles, which essentially means that I have added more to this, so it will become 0.5, and I have to find the new volume V2. okay, so very, very simply we can solve this problem. Okay, and this will become 0.35. If you solve this further, you will realize that the answer comes to 11.64 liters. Okay, and again, the problems are simple. You have to read the problem and translate it into mathematics through the laws, the mathematical equations that we have studied. Okay, and that is where you have to do some practice. Head over to DoorstepTutor.com, where we have several such problems already given, so you can solve those they are given with explanations and solutions, so you will not be stuck. Thank you.